So for everybody, we are watching a build in process. We're replacing some coils with other coils that have different properties.
Hey, what's up, everybody? How's it going? Just real preoccupied. Sorry, I'd be more engaged. But I feel like my work is engaging.
We do. Yes, we do.
Alright, so continue on. So we start with a 14 gauge coil. Then we go to an 18 gauge coil. Both of these coils have cores in them. And they are very much smaller bobbins than all the other cores. They're old quarter-pound bobbins.
Nice.
Quarter-ounce bobbins, my bad.
I was gonna say QPs.
4-ounce bobbins. My fault. Yeah. 4-ounce bobbins. Yes, indeed. We're running a series circuit. Yeah, we're going to run the series circuit all the way around. We're going to have like no specific drive, generator coils on this build. So 14. You know what we got to do? We got to put the 16 gauge coil in here first.
Okay.
Pass me the glue.
Glue. We're running on the glue. It's gluey.
Thank you. Alright, so we got that one core right now that's going to hold everything in place for timing. And it's really low to the table, so I'm just gluing to the table. Man, it's like it just moved. There it goes. That's dead center pretty much.
Nice.
Let's spin it. We're starting with the single file coils. So we got 14 gauge, 16 gauge, and then 18 gauge.
This one is the 18?
Mm-hmm. This one in my hand?
Yep.
Yep. Alright. So
nice. Let's see how strong these are. Nice.
Alright, no core. It's alright, they don't all need cores. We actually only need one core.
And we have one right there.
To hold it in place, basically, so I can time everything right.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop a like, subscribe, leave us a comment, let us know where you're from if you're working with pulse motors at home.
Or if you just like to have fun putting stuff together.
Boom!
Yeah. Alright, so 18. The next logical step would be 20. We have a 20. Boom. 20 gauge. Single file.
I like where you're going with this.
It's going to like step down, like a very small step each time it transitions into a different coil. We're going to have it hooked up DC with directional diodes, direct diodes, rectifier diodes. That's another core though, I mean, but what do you do, right? It's a 20 gauge coil, and that's the next step that we have available to us. I don't like that.
Yeah, that's shaky.
This, yeah.
Oh, I see.
So we gotta lift up both of those. We gotta take this off.
I love your dedication.
Excuse me. Thank you, bro.
Mm-hmm.
All right. Now we're gonna need more glue in just a second.
Yep.
All right. Thank you. It's gonna be like just enough.
Ooh.
So that when it sticks, it's pretty solid and it bonds.
We're setting up a circuit for pulse motor
Just coils.
and
Well,
the coil part.
and the transistors. We're gonna use one transistor on this build.
Okay.
So we're going 14, 16, 18, 20, and then we're gonna go 24. And that's already pretty much right here. That's 24. And then 26. It's gonna be this one or this one. And then we don't have any 28.
Okay.
I don't have any 30 coils built either. We have, where'd it go? Oh yeah, this one for 32. I mean, I don't even think this thing will start running if I put that on there. That's 18,000 turns. So we're kind of like, well, I just been dying to see if this is going to work.
Right.
All the connectors. I'm going to be putting them in different places. We need one spot for a trigger coil.
Right.
That should be all good. This is a completely on-set setup. It doesn't need to be on-set, just some of it needs to be on-set, but this is completely on-set. So it can be offset, and they're going to be static coils that are actually just going to change the frequency of the electricity going through the circuit. Like for instance, that big coil over there acts as a resistor, a 1,000 ohm resistor. more like 1200 ohms. All right, so that's 24. Now I'm not saying this will be super spectacular or anything because I just had a parallel circuit hooked up, which I probably will end up going back to. I just had an urge to see what this would be like. All right. Let me get these off the table. Got some boxes for 3D printed stuff down here.
Nice. Hey everybody, welcome to the channel.
Hey everybody, what's up?
Drop us a like, subscribe, leave us a comment, let us know if you got a passion for magnets, electromagnetism, or pulse motors.
I'm just building stuff. You want to put something together? This is what, this is it, man. We're putting something together.
Yeah, collaborating with the community. We love it.
Let me see here. 26. That's this one.
26. That's a nice one. Look at all those strands.
It's a 26 gauge 4-filer coil. It's got four strands of 26, and it's about 200 turns. So it's about 800 turns altogether if you link it in series.
Mm-hmm. Let us know if we got any coil lovers out there watching.
Coil lovers. I think everybody's a coil lover.
Yeah.
Now, if I wanted to make it like a true 4-filer, I'd make it like 50 turns. And be 32 gauge. Man, you gotta love it. You gotta love it, especially when it doesn't work the first time.
Right.
I just caught that and I bent it a little bit, so I got mad at it because it was in the way. All right.
Nice.
Now there's a small maglev on that. I could even show you guys real quick. Little tiny, and little tiny.
Yep. Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, leave us a comment, let us know where you're from. If you got any projects going on at home, do it yourself style.
All right, so do we want to put in? We got 2 slots left. We got 1 slot for the trigger coil. Now I'm gonna unhook all these.
Okay.
We're gonna do it so it makes sense.
Nice catch. Hey everybody, thanks for dropping in. Drop us a like and subscribe. Let us know in the comments if you love working with pulse motors or have any questions about pulse motors.
This is a an 8,000 turn trigger coil that is bifilar wound in for 4,000 turns.
Nice.
And it doesn't even need to be anchored down in any way, really. I'm wondering if I should just, well, I gotta move it, but yeah, that good.
That was a good one.
Okay, so let's go through what we have left for coils put in the last two slots.
Okay.
We're at 26. So we have 32 gauge coil. And we're gonna put this on there. I just made up my mind about that.
Okay.
So this one is gonna go in this spot. And the 32 gauge coil is gonna go right next to it. I need a little bit more glue.
Yep.
Thank you.
Mm-hmm.
All right, we're good there. That's good. This can go over here now. So in my mind, what we're creating is a huge coil that has a step-down strand of each gauge. We're going to see what that looks like in just a second.
Yeah. Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe. Let us know in the comments where you're from.
Do we even need to put a coil right there? I think we do.
In the open spot?
Yeah.
What kind of coil do you think needs to go there?
Either another 26 or a multi-filer coil. We could put one of these in there.
Yeah.
Yeah, this one.
Nice.
It's connected. There we go. All right. So this one goes 18, 20, 32.
Nice. I like the multi-filers. And that's going to go right here.
No, this is really. I'm gonna have to undo this. Yes. All right. My bad, folks. Okay.
So the setup for the experiments is important. You know, it's important. This is the build time, and it's fun.
Yeah, and the fun part really is that I sincerely, with these cores in the drive circuit, have no idea how this is going to go. So I don't normally put cores in the drive circuit. It's usually always to make the electricity generation better. And for me, they've always been different.
What do you guys think at home or at watching?
And I don't know what having them together makes it so much better. I don't understand what it is. I've hooked them up in the same way, kind of. Usually the trigger coil inside the coil is what gets me to go the other way, because it's like the outside coil is way more powerful. There's way more going on there. I like it being what I can see. If I can see it, then it's cool. But high frequency is way different than that. You can't see the high frequency, and it does really cool stuff. So it's kind of like a paradox. But as for this right here, this frequency, this style stuff, it's, you know, it's not the same as the high frequency stuff. But I got some lowdown on how to make those coils, and I think I'm going to give it a shot. The down low. Alright. So now we're going to start hooking them together.
All right.
And this is what the connection looks like right here. Boom, diode, connector, connector. That's all we need to do.
Awesome.
It's all going this way, like this. And then, like to do the other way, we gotta take it all apart and put it together the other way.
Let us know in the comments if you have any questions.
Alright, that's good. Make another one of those things. Hopefully I have enough of these.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe, leave us a comment, let us know where you're from, let us know if you're working with pulse motors at home or doing any do-it-yourself projects.
My email is now on my page, my channel. So yeah, hit me up, and we'll get started on collaborating and communicating.
Yeah, we love co-creating with the community.
I didn't know it wasn't on there, so I apologize for anybody who's been trying to get a hold of me via email. I have remedied the situation. Alright, first 4-filer coils going in.
Nice.
Alright, so this is a 24 gauge. wound in AC series. I found that when it's inside the coil, it's good to wind those in AC.
Nice.
And then when you connect a coil to another coil DC, it works out pretty good. Yeah, man, I didn't think I'd run out that quick.
Of connectors.
Yeah.
There's some on these. And
Oh,
on
good.
these. And there's some here.
I need these kind. Yeah, good. All right, cool. We're cannibalizing as we go. What I had set up before was really, really good, so I'm hoping this is going to be really, really good as well.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like. Subscribe if you love pulse motors. Let us know if you're working on any do-it-yourself projects at home.
And then I got a question for the see this diode? Is this one better than the rectifier? It's a Schottky or a Zener. I'm not sure which one it is, but it's one of those two.
Yeah, and it looks fat. The fat diode.
But this one handles 1,000 volts and 3 amps.
Nice.
Alright. Now. Oh, you should have seen me working with my 20 filers and my 10 filer coils.
That must have been hard to keep track of.
I'll bust it out here. I got 2 of them in this thing over here.
Nice.
Yeah, it's pretty spectacular. And then trying to hook up 10 transistors to one coil that's literally this big. You know, it's fun, but you're going to have some wires that might be touching one another. If you don't have like a switchboard like this big.
Right. And we've gone through a learning phase there.
Beyblade.
Right on.
Heck yeah, man. I swear she... Have you ever seen the movie Armageddon? There's this guy in there called Hound. And he keeps on telling the authorities that she didn't tell me how old she was. I think it's really, it's truly like humor that I don't even know is allowed, if it's allowed anymore. I know I can't do it because the authorities really will be at my door.
Welcome to the channel, everybody. Thanks for dropping in. Like and subscribe. Let us know if you're doing any do-it-yourself projects at home.
Yeah, okay. No, I understand. I apologize for...
And what? We're hooking up these in parallel?
No, this is series.
All right, we're hooking it up in series.
Yeah, if we could just, I don't know. I'm going to try and stay away from humor. I'm not even good at it. So, yeah, it's just not my faux pas.
Boom.
Okay, so this is the connector. How did I put it? Or did I already use it?
There's one with the diode right here.
Oh, see, man, I can't even see it, and it's right in front of my face.
You good?
Yeah, that's trippy. I just realized that I made a joke that wasn't funny, and I'm still thinking about it.
Well, everybody misses the punchlines every now and again.
Nah, it's not an every now and again thing with me.
All right, I have to use the restroom here in a second.
We should get one of the kids to hold the camera then.
You can't just hold it for 5 minutes.
Well, yeah, but I gotta stop doing what I'm doing.
That's okay.
Yeah, I can do that. I'm just saying.
Hey everybody, welcome to the channel. Thanks for dropping in.
All right, we are down to the last one.
This is exciting, watching this series hook
Yeah,
up.
If you sense any tension between us, we are brothers. So there is definitely a little bit of tension there every now and then.
Oh yeah, we got the sibling thing going on for sure. And you can see, since we've used the connectors, it's been a lot. He described that a little earlier in the live. It's been a lot smoother with how many wires we're actually using at any one time, because he loves doing the multi-filer coils like this. So there's many strands and many wires in play at any one time.
I need one more.
One more connector. Uno más. There's one. It's got glue on it. Oh, right here. They both got glue on
Oh,
them.
this one's for this.
Got it.
So actually I need two more.
Dos. Here's one. Is this one?
Yes. Oh my God, bro. Thank you. You hit it and then you found it.
I did.
I hit it.
Well, I was going in there for glue sticks for sure.
So you knew it was. You kind of knew it was there. Oh, that's awesome. Yes.
We got it.
Got it. All right. I'm gonna need. That's what happened. I need a lighter. Thank you, sir.
Yeah. Fire. That's the enamel. And for a smoother connection on the connector or clips.
Alright, now I gotta flip this around. Alright, that's done. So close.
Dude.
Wow, we're so close, and watch it just not do anything. That would teach me a lesson for sure. It might just be this coil that I'm hooking up right now. 'Cause it's got so many turns in it.
Well, that's why we do it. So we'll know if it will work. That's part of the end game.
Yep.
It's just to know if it works in this way. Welcome to the channel, everybody. Thanks for dropping in. Drop us a like, subscribe. Let us know in the comments where you're from, what you're working with at home, DIY style.
One more 32 gauge strand to go.
Let me come closer so you can zoom in.
Zoom in, please.
Yeah. There we go. And you're doing excellent for having giant fingers and tremors.
Could shake the freaking ground.
Great. Great work, bro.
Alright, so there, it's all hooked up except for the transistor and the trigger coil. The trigger coil is easy, transistor's easy. this is just going to take time. I'm sorry. It's just going to take time.
You got this.
Alright. So that's the emitter. This is the collector.
Let me get a close up on that.
So we connect the end of the circuit to the collector. Wow.
Yep, you got it. That was cool. Or weird.
Yeah, it was definitely weird. Where did it go? There it is. Alright. Because that one thing was kind of like in my way.
Right.
And I was trying to move it without having to put everything down because there's really nowhere to put anything.
I think you managed.
I think I did all right too. All right. So now thank you. So close. Is that not going to go through there? What's up?
I got shocked.
There's no power going through there, bro.
I know. Doesn't mean there's not anything in there.
Is that what's being said right now?
No, that's what I'm telling you. And we've measured it, bro.
When it's moving.
No, when it's still.
I've never met. Oh well. Once there was a 6-volt discrepancy that
That's
nobody could explain.
That's
it
the one I'm
wasn't
talking
moving.
about. That's exactly.
Yeah.
I felt it in these 2 fingers. And then I felt it again after I pulled it out. So there was definitely something.
Static discharge. Maybe.
Possibly that. It was small, but it felt like 2 pins in there.
Wow, that's pretty awesome then. This is definitely got some latent energy in it.
Yeah.
Yeah, this part I was dreading the whole time because so many parallel circuit the other way.
Right. You are the man. The deconstruction, reconstruction, cannibalization, and making it happen.
So before I start my next experiment, I'll be cleaning up these wires. Alright. That's the ground for that. And then we need a power. There we go. All right, are we ready?
Boom.
I'm sure a lot of people are ready. I'm ready. Let's just start with that.
2.5.
This is it. This is it. We're gonna take off some coils now. It's too long.
Got it.
That's what I thought it was gonna be like, but we're just gonna take this one off.
Okay.
You should check this out. Uh-oh.
What's this? The coils.
With 25 volts going through it.
With 25 volts going through.
Alright, so that moved, so I need to fix that.
Okay.
No, it didn't move.
Nice.
No, it's not nice, because it's making a lot of noise. Alright, I'm gonna do this real quick.
Okay.
It was just for fun to put the generator coil in the circuit.
Alright, I'll be back in 5.
Alright, man. Check you later. So basically what we did is unhook one coil. There it goes. Just like I thought. It's just too much of a coil for how little voltage we have going through the system. So this isn't going into the 14, into the 16, and the 18, and the 20, and the 24, and the 26, and the multi-filer coil, which goes 18, 16, 32, and that's the end over there. Then we have a generator coil up, and the trigger coil up. And this wave that is going through my drive circuit's pretty wicked. Why is it bouncing like that? I think it's the cores that's making it bounce like that. Wow. Might not be able to do the maglev if it keeps doing that. I think I need maybe some graphite powder on that. Because the cores are making it bounce. But yeah, it's going pretty fast, don't you think? So this one, the cores are uneven, is what it is. Or maybe, I don't know. I kind of want to leave the mag on there, but it isn't going to work. Unless I got an idea. This one over here that I'm currently decided to start over, actually. So now we have another one. We're going to double double up. Hopefully that'll keep it buoyant enough. Keep it so it won't, connect. The two magnets were grinding because there wasn't enough. Well, they're kind of sticking up now. Let's see what happens. That hardly seems right, though, I mean, I know that a few of those coils are hitting right now, but I don't know if all of them are effectively on there. I'm going to put another big magnet on the top just to weigh it down a little bit. Let's see if that'll... See how much space we got there. I don't know. Maybe we just take it all off and let it ride. So that's 24 volts and 100 milliamps. We're going to check to get an oscilloscope on this. I wish there was a way to make this wave smaller because it's covering the whole screen. I know it's not like that. Hey bro, what's up?
What's up? Let me grab the camera. Sorry for the hand. Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe. Let us know in the comments where you're from, if you're working on any pulse motor projects at home, or any other do-it-yourself stuff.
Yeah, man, we just reduced our need for 3 transistors.
Nice, and it's going good.
My bad, I just heard the crinkling. I didn't know what it was.
Yeah, I heard it.
Alright, so this is not that great.
Okay.
It's stable, but it's not that great.
What are we looking for?
Well, it's all the way up, but it's only, what is it? 2.5 watts, 2.5 watts in. Actually, it's pretty
Yep.
good.
2.5 watt.
It's pretty damn good, actually. I just looked at the voltage and I freaked out, but
All right. Anybody watching had any questions for us, drop them in the comments.
so we're drawing that much less amps in the circuit. Usually, at this point, I wouldn't be able to turn it up this high because I would be drawing like up to 5 amps
Yep.
because of the parallel circuit. But this is awesome. So now, question: if we're gonna do parallel circuit, how are we gonna do them?
Take a look. How would you do them?
Well, let's look over here real quick. We got more of these little green coils over here. So we have another 14 gauge and another 18 gauge. We could make those be in a circuit with another coil.
Okay.
Yeah, that's about it, really. Could like make a 16 or 14, 16, 18 like it is right here.
Mhm.
And then have that be one circuit. And then have, 14, 18, 16 be another circuit.
Thanks for the like.
Appreciate it.
Welcome to the channel. Let us know in the comments where you're from. If you're working with coils or pulse motors at home.
Yeah, I think I have an idea now.
All right.
This is a great idea though. I mean, it's whipping right along. We should probably do a tack reading real quick, just because.
$473.
And that's with the power all the way up, man. That is not good for speed.
All right.
It is good for power though, because the amps are way down that it costs to run this thing.
Hey everybody, welcome to the channel. Drop us a like if you like pulse motors. Check out this design. We got cubic magnets encased in a 3D printed rotor. And we 3D print most of our parts.
Alright, so this is how we're going to do it. We're going to do our 16 gauge. Oh, that's not going to happen first though. So we're going to do 14, 14, 16, 16, 16, 18, 18.
Okay.
Oh, God. I'm not really
You got
focused here. Sorry. My bad. No, it's not gonna do this. There, should stay. Alright, so this is the one that's got to come off. And the 14 gauge goes on. I need some more glue, sir.
Yep.
Thank you.
Mm-hmm. Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe, let us know in the comments where you're from, and if you've got a passion for magnets.
Oh, yeah. So 16 and 18. We're gonna roll till the glue runs out, and it's really close.
1, 2, 3, 4, 5 sticks.
So we're going to keep it in a relative order, descending order, from, well, it's going up, but it's in the thickness that I'm talking about. So thickest, then to thinnest. You know, I kind of want to make it go thinnest to thickest. So we'll just hook it up in reverse for the single file coils. And if we have any multi-fiber coils. We'll be alright. Hooking those up too.
What's up, Eric the Actor? Welcome to the channel. Yeah, we making the pulse motors. Drop us a like.
Brushless motor.
This is a brushless pulse, and there's a levitation.
DC motor.
Get some footage of that.
I'm really looking into how to do high frequency AC, move aluminum kind of thing. That's what I need to get into. But this is a brushless DC motor, pulse motor. Nine magnet rotor. We're just making an assortment of coils right now.
Here's a close look at the rotor and the levitation. You can kind of see it underneath there.
We're nearing, we need to put two 18 gauge coils out there now.
18. Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe.
So that did work out pretty well, but I mean its max speed is 500 RPMs the way it was before.
Right.
And I think also what we're going to do maybe is do a parallel circuit.
Okay.
And again, that is a maybe with all this thick wire out here. I don't know if that my transistors will be able to handle that. I'm definitely going to do the 16 gauge parallel circuit because I've done that one before.
And what kind of torque do we got on this guy?
Kind of torque. This is a pulse motor, radial pulse motor. There's like no torque on this.
No torque on this one.
We'll have to see. I mean, I got to print some fan blades that we can attach to the top of this.
To get some good measurements on it.
And then we'll be able to tell if it can handle a load or not. Right here. There we go. Oh, I think I need more glue.
Glue.
Thank you.
We are working with pulse motor.
I'm doing different coil spreads, seeing like the power I get out of whatever I do. And I just realized that the step down only goes about 500 RPMs, but you only need to put 200 or 2.5 watts in. But I only had 25 watt volts to work with, and it wasn't using amps, so
We're trying another setup.
but this, we're gonna see. This is probably gonna be really good.
Hey everybody, thanks for dropping in.
Oh, I know what I gotta do.
Drop us a like, subscribe if you love pulse motors, electromagnetism, do-it-yourself projects at home. Let us know in the comments where you're from, or if you got any questions about what you're looking at.
That's hitting right in the field, I'm pretty sure, if I'm right about how the fields work.
Missouri in the house, Washington in the house.
Hi guys.
We are up in Michigan.
Alright, so that's a so yep, I got an even better idea now.
What do you got?
We are gonna, this sucks, but I'm gonna have to move this one, move these two down to here, and we're gonna make 3 parallel circuits with these and 2 multi-fiber coils. So we're gonna have 26, 226s.
Where do you get the wire from?
Amazon.
That's, yeah, we don't buy in bulk yet. Or we do, but I'm just playing.
All right, so actually,
I need to get a new headlight. I wish I knew how to wire my car.
So we're gonna do, that's my fault, we're gonna do 2 series circuits.
Okay. Nicely done. You're very efficient with that, man.
It's the kind of look you have on your face after you, like, you know, I mean, you know, like, there's no way you can stop me, kind of, to the fucking toilet.
What do we want to power? We like to test a lot of different things to power. Right up. We're usually trying to get the fan down here to work.
I tried that once, twice.
Oh, my bad.
The light, we do the
Excuse
light.
me. Usually doing the light, yeah.
And the other pulse motor, we try and, like, we can run another pulse motor out with this pulse motor.
That's right. And multiple pulse motors.
Yeah, the fan, we're gonna work on that, but you can't do it with what I have here.
Right.
It's a different kind of energy type. It's not DC energy, and therefore the initial DC energy isn't gonna do it. And then I was, I illuminated this coil. It had about 250 volts in it and about 0.6 amps. Wouldn't light it up.
We appreciate that.
Yeah, but yeah, man, we're gonna print some fan blades for the rotor, and we're gonna get it going. We're gonna see if it'll still move. But yeah, I need to glue these down real quick and give this thing a test spin.
All right. So this live definitely has a lot of the actual build in it.
And we don't always do this.
Right. Most of them are set up for experiments, but seeing some of the work behind the scenes, just so you know what goes into setting up the experiments for the lives and our videos.
With glue, of course. I mean, this is not an optimal by any means setup, and we're using glue. I want to develop, once I develop it, you will know, because it'll be all that we use to set this up anymore.
Hey Jacob, welcome to the channel.
Like holders for the coils, I've had a few renditions of holders for the coils, but none of them have really, made me happy. So got to keep working on it. And then it's top stabilization, or maybe even top stabilization in an upper platform for another pulse motor, maybe a smaller one up here.
Yeah. Jacob, we are building a pulse motor setup.
Yes.
And it's pretty cool the way he's doing this one.
You hear something knocking?
Yeah. What could it be?
It's probably from underneath.
Yeah. See if I can get a view of that. I think it might be all right.
God dang it, dude.
They're moving. Oh, well, they're magnetic, so they're always
No,
hitting.
it's like I have them lined up and then it's not lined up when I come back. It's messed up.
Got it.
So we're gonna do that one again.
Okay. Hey, everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe. Let us know in the comments where you're from. If you're working with any magnets or pulse motors at home. If you got any DIY projects going on at home.
I have an accounting degree, by the way. Wherever you guys thought I was just a nerdy-well.
We got an accounting degree. And you don't need an accounting degree.
Yeah, you don't need any degree.
Having
You don't need
fun.
an accounting degree. You don't need any degree to have fun.
Thanks, Knuckle. Appreciate that.
Stop moving, goddammit. Some sturdy plastic.
Mm-hmm.
Nice and flexible. I'm sure it can get pretty hot too, and that's why I use it.
We actually just took them off their mounts and we're trying lower center of gravity experiments right now.
It's actually way better being lower than it is being higher. Because of my base is made out of wood, so it can't, because the shaft goes like this.
Yeah, just our foundation. As soon as we get you can kind of tell there's a bow there. But it's pretty cool.
So we're gonna test one circuit at a time. Connect one transistor at a time for this parallel circuit. So we're going from this coil to a 16 gauge. To an 18 gauge. And then from the 18 gauge, we're going to go to the multi-filer's 26 gauge. Alright, and I think that's all for that one. Alright, let's hook it up.
Hey everybody, welcome to the channel. Thank you for dropping in on this Friday afternoon. This is Papa Bale, and we are working with pulse motors. Let us know if you have any questions.
Alright, so there's the power for that. And then we're going to take this is the collector. Here's one circuit complete. Oh no. We need plug. Oh, it is plugged in.
Nice.
Nice. All right. Now,
Let me get that.
go 2.5 and see what happens. It's definitely working.
Yeah. What kind of materials did you use to print this rotor?
And it's Hyper PLA, white, from Creality. See, we're still drawing 0 amps.
Mm-hmm.
We haven't even hit 0.1 yet. So, I mean, it's doing all right. That's just one. So we'll hook up the parallel one. All right, now we're up to 0.1.
There it comes. I think that's a good result.
Me too. I think that's awesome. If it's up to like 400, I don't think it is yet.
Not yet.
$325.
Hey, Anonymous, welcome to the channel.
This is out quite a bit though, compared to the other one.
Yeah, that's a gap. This is a pulse motor. And we are working with electromagnetism. Hey everybody, welcome to the channel. Thanks for dropping in. Yeah, Jacob said that's such a low current draw. That's really cool.
Yeah. It's gonna be more than the last build though, a little bit. If I turn it all the way up,
Right.
I don't have to do that though.
I feel more confident now.
You do?
Having gone through that, yeah.
Okay, so we're at 16, drawing 0.2. Now we're at 20, drawing 0.4. So a little bit more amp draw than the last build, but we're only using 4 coils instead of 9.
Yeah, that's humming along now. So that's running at around 5 watts.
547,
Nice.
550. All right, let's hook up the other one
All right.
and move that one coil in a little bit. See, like no torque, really, at all. Okay. We're just gonna move that one in, and we're gonna hook up the next circuit.
So what are some ways to get more torque?
Are you asking me? Or are you asking the audience?
Oh, Jacob asked you. Sorry.
Yeah, I have no idea.
I remember you were talking about the different
Gauges?
type of coil. Yeah.
Yeah, like maybe a thicker gauge will get you a little bit more torque in a radial motor, but it's just a little bit. It's not anything that's going to crack a tree or anything like that.
Okay. So anybody that is knowledgeable there, drop some wisdom in the comments.
Yeah, show me how big an idiot I am and tell me how it really works. Like, how do you make more torque? Because I have no idea.
And idiot's not the right word. I'd say it's
Right.
current understanding, and then we further the understanding.
Thanks, bro.
Yes.
I just spitting it out real quick. That's exactly what I meant to say.
You got it. Yeah, we started with zero background. Basically, just he has
I have an accounting degree.
accounting degree and a love for magnets. And self-taught, and then incorporating learnings from the community lately. So it's been pretty cool.
I made that gyroscope just by looking at a picture. I think that's pretty good.
Check that one out.
That one will move in opposite directions. And the DC rectifiers in between each coil change it a lot, and it's not necessarily for the better all the time. Sometimes it's better to run a motor in AC. Or, the rest of the motor in AC. It's going to go in DC, but once you get it through the first coil, it changes.
Okay.
Nice. We had 8 of these. That is brilliant.
Perfect.
Perfecto. See, this didn't take barely any time at all to do it.
Right.
Yeah, if you watch a replay of our live stream last night, you will see that there's going to be a design update in all my rotors.
Mm-hmm.
All right. Need a transistor up in it.
Jacob asks, so using the coils converts the DC power to AC? Question mark.
For what I know that if they're not, like if a coil isn't directly hooked up to the drive, that coil on the rotor will generate AC electricity from the magnet passing it. Now, I'd imagine, because the reason I say it that way is because I don't use any of my drive coils for generation.
So
I prefer transformer way. I don't prefer whatever that is. I don't understand that. Doing it, and these are single file coils, so yeah, I don't get that.
Okay.
But yeah, definitely when the magnet passes a coil, it will generate AC.
And this is a 9 magnet rotor?
And I do think that I'm right about that. Yeah, 9 magnet rotor. That when after the DC passes through the coil and into the next coil, then it will become AC. I'm not 100% sure about that, but I think there's something in the coil that changes it.
Right, what an inverter does. Okay.
And all these inverter things and whatever, I believe, can be made out of coils,
Okay.
and that's it.
They just,
coils.
if you bust one open, they just might be. Yeah.
You just gotta have the right coil, right gauge, and the right ohms.
Because it's got to step down that power, and then stepped up
Yeah.
the opposite way. Yeah. Hey, Aaron, welcome to the channel. We love this stuff too. Yeah.
Hey, Aaron. What's up, my man? All right, here we go. We are disconnecting all of the leads from that awesome coil. All right. Bam, I'm putting it over there. Damn, I wish I wouldn't have put it right there. Can't see it. Oh yeah, that's right. Let's see about this one. This one looks burnt to a crisp. Is it a 36? Yes, this is dead. I'll test it later just to make sure it's dead. I'm looking for I need wires. This one's not connected to anything.
Nice. So Aaron said I build zero connects boxes for people on week-long bike trips or hiking in the mountains. And this,
What is that?
I'm taking it, this gives them power. I'm asking Aaron.
I'm asking Aaron what it is. How do you make it?
Yeah. That sounds amazing. Because I love being out in the wilderness for that long.
So it like operates the radio and stuff like that? Maybe a cell phone, can charge a cell phone?
And definitely net zero is the way to go.
Or is it Wi-Fi of some sort?
The wires on the coils are wrapped tight.
Very tight.
Yeah, he does them each by hand. We have an auto machine, and then we have a hand cranker too.
Yeah, I know about the tightness. Tightness. This coil is so tight, it's literally like 3.5 pounds.
Got it. So yeah, that's the connects boxes mean solar to inverter to house with batteries and generator.
So it's like a kit. That's awesome. Maybe I should get one. But I'm in Michigan, so I don't know.
Well, yeah, our utilities. But if we get if we get the cabin, my man, we got this.
Yeah. All right. I need one more cord.
And we'll have like a crowdsourcing
I
build.
need one more cord, sir.
One more. We
There
got.
it is.
I think there's a yellow one if you need it. Yep.
Sweet. Bingo. Get off my oscilloscope. 1, 2, 3, 4, 5. It's about 6.5 or less. Oh, of course. Oh, with the power off. I didn't give it power. Oh, I did. No, I didn't.
Yeah, agreed. Actually, down in the city, down in Detroit, a lot of the old residential has been turned into urban farms, and there's a lot of innovation going on with the rain catchers there. It's pretty cool. Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe. Let us know in the comments where you're from. Let us know if you're working at home with any do-it-yourself projects. It sounds like it's doing something.
It's not timed right.
Okay.
Yeah, I don't know what's wrong with this.
And when we are in, we are in the lab today, and we love to show how we troubleshoot.
So this parallel circuit isn't good. So I gotta think in my head what I want to do.
You're good. And this is just some of the stuff we don't,
Like right now.
like it's not always in the videos. And I
So
think
it's not like it's not working, it's just not good.
that's
But
That's-
it is drawing less than,
100 milliamps,
yeah. And it is working.
maybe 50 milliamps. But yeah, and you can hear it. It's trucking.
No, it's just moving.
Just moving. That's a good, yeah. Wrong descriptive.
So, I think I'm gonna put it back the way it was. I'm gonna put all the green coils away.
Okay.
Could you cut off the power?
Yes.
Thank you, sir.
Mm-hmm.
For one, they're not high enough, so I don't like them for this build.
Power is off. And I am going to be right back, and I will let you guys watch the transformation in real time. And the cameraman will be right back.
Seeing, like, this is worth it though for me, because every time that I get something that's like supernatural, man, I get thrilled out of my gourd, man. And even if there's some guy out there that already knows what's gonna happen, he isn't opening his mouth. So I'm gonna find out myself. This is how I do it. Some people do it on paper. I don't appreciate that, really. I think it's a way to do it, for sure. And the schematics is another thing, man. I can't read a schematic to save my life. Very true. Can't do it, man, because this is a round thing and the schematic is made out of squares. It doesn't make sense to me. Shouldn't be my job to change it in my mind. It should not be my job to do that. So, like, when I draw pictures of my stuff, it looks like what it looks like. WYSIWYG, you know, what you see is what you get. I'm sure a schematic is the same way. It's just I don't know how to read them. Even with the legend, it's not about knowing what the symbols mean. It's about just it being a square when it's not a square. And I know why it's a square, because you can use a ruler. That's why it's a square. You're just too afraid to make a line that isn't straight. I get it. I'm very, like, afraid that people are going to get my drawings, and a lot of people don't understand. Or they want me to draw it the way, in squares, the way everybody else draws it. Where is that? Here it is. That's a design for my generator. See how that's not a square, but it has the same legends. A curly line is a coil or an inductor. Straight line is a core. Circle is a magnet. It's really not hard to read at all. But I don't know. I don't get it. We're running out now. It's all right. Got 2 sticks left after this one. But there'll be more here tomorrow at 7 in the morning. Because I haven't sat down and put the time in to create brackets and coil holders and all that stuff with my 3D printer, but I do need to do that. So it's going to be, each circuit is going to be one of these 16 gauge coils and one of these 4-fiber coils in it. And they're going to be at 120 degrees on all sides pretty much. I don't know, he's probably smoking. Don't know what he's doing. He just decided he needed to leave, so he left. And he'll be back though. Yeah, I wish he was here right now. He could show you close up of all what's going on here. But 16 gauge coils are backed out about a 1/2 inch. And then these coils are going to be right up next to it. So that's how we're setting this up. It's just too bad that these two are 26 gauge. And this is a 24 gauge. He's back.
I'm back.
Ladies and gentlemen, the cameraman is back.
Oops, let's get some light.
Alright, so 24 gauge will go first. Make sure that's lined up. Yeah, that's good. That's good. So I might end up just putting it down on the ground basically, right on top of the flange, instead of being on the maglev like it is right now.
Okay.
Can I get some glue?
Mm-hmm.
Thank you. What are we down to, 1 or 2?
One more left.
Thank you.
Hey everybody, welcome to the channel. Thanks for dropping in. Leave us a like, subscribe. Let us know in the comments if you have a passion for magnets. Doing any do-it-yourself projects at home.
Heck yeah, man. This stuff is fun as long as you don't destroy your house. And no, my house actually looked worse before I moved in.
Boom. Thanks for the sub.
Yeah, hell yeah. Thank you. All right, now we got 2 transistors. We're gonna need to hook up an additional one. Okay, so this goes here. And these bad boys. So this is me reverse doing things backwards. So this would go on like this. Just, you know. Alright, that one's hooked up. Give that one a rip, see if it's working properly.
Move this one real quick.
Yeah, please. If you see something in your way, you can move it out of the way.
I was conscious of it before.
Oh, yeah, that makes perfect sense. That makes perfect sense too. In order to test the circuit out, it must have power.
Power.
Second time I forgot to plug it in. So I'm thinking it's going to have a much larger acceleration phase than anything, say, 16 gauge by itself. It's definitely not slowing down though.
Right.
This is 4 volts in. So I'd say it's definitely a win. We're going to do it till we get 1 milliamp though.
Okay. Hey everybody, welcome to the channel. Thanks for dropping in. Leave us a like, subscribe, let us know in the comments where you're from, if you're working with magnets at home. Trying to get the, we're looking for that 100 milliamps to pop up.
Well, I'm going to continue hooking this up. I'm just going to hook them all up.
Okay.
because it's working. It's just, I don't know. Maybe it's not drawing the amps like I thought it would. Yeah, today's been a really bad luck day.
For functional.
For everything. Just for me.
Share us some of your luck, crowd.
Please. I'm feeling kind of low right now.
Hey everybody, welcome to the channel. Thanks for dropping in. Leave us a like. Think about subscribing if you enjoy pulse motor content. And today we are in the lab, so you're seeing some of the behind the scenes builds that you don't really get to see in the videos or other live streams.
Naturally.
English.
See, look at it spinning though.
Mm-hmm.
It hasn't stopped spinning.
It looks like it's going faster.
And there's no power going into it, so that's why I had it set up like this. So that's now one more. All right.
Hey Flo 3D, welcome to the channel.
What's up, Flo?
He asked, do you charge batteries with this motor?
I'm sure if I hooked it up the right way, I could charge batteries with this motor.
Yeah.
But then I'd never be able to charge them any other way ever again.
Oh yeah, that's a good point.
Okay, so they get to be totally dedicated forever to this motor.
I forgot about that.
Once you like spike a battery, it doesn't charge the regular way ever again. All right, so almost done here. Yeah, I don't work with batteries really. I mean, there's an age of abundance coming up.
Yeah.
Batteries is going to be a big part of it, but they're going to be hooked up to the grid.
That's right.
Big batteries are going to be hooked up to the grid, and you don't need to go off grid anymore to get free energy.
Yeah, I hope they can do it right.
It won't be a matter of money in the future, especially when crypto expands.
Oh. Yeah, I think energy will hit zero marginal cost within the decade.
And I have no doubt in my mind at all that that'll happen. Because the people that want it to happen are going to be more nasty than the people that don't.
Right, that's true. That's true. And that's the way it happened when fossil fuels took over for animal power and steam engines.
This one will be a lot more quick and behind the scenes than that. But yes, definitely the same idea.
Right.
And it's open source too. Open source has definitely cracked the wall in like everything that was ever a secret.
I love it. I think I think of it as you can copy and paste and then tailor it to your need.
Exactly. Copy and paste from the patent office.
Yeah, the commons. Yeah.
Yeah.
So that's the other piece that people really don't think about is the market for ideas is the commons as well. So you can publish it open source. Just not many people do that.
That's going to change.
I agree. Hey everybody, welcome to the channel. Thanks for dropping in.
I would go open source just to undermine a fool that would try and
Patent it.
well do that just to make it so other people wouldn't be able to use it readily. I mean,
Oh yeah, we got
come on now, you got a great idea, you better freaking share it.
we got some umpteen examples of this.
Yeah, people don't like my mentality very much, and that's okay. I appreciate that.
You're good. Sometimes we need
Swift kick in the ass.
Right.
See, that's my mentality.
to be you're right. You got it, bro.
Like, you want me to clean up? Swift kick in the ass.
We're in the lab.
In the lab. Dun, dun, dun. All right, let's give it a crack. I need to go that way, sir. Put it up to 6. Man, I'm so upset right now. This isn't my plug and play like it used to be. No, I'm good.
Mm-hmm.
Yeah, something's not working.
Thanks, Flo. Appreciate that. Built a Bendini motor years ago. And Flo said that they will be back.
Nice.
Hey everybody, welcome to the channel. Thanks for dropping in. Leave us a like, subscribe. Let us know where you're from in the comments.
Oh, right on. Could you just cut that?
Yep.
All right. Power yet again on the 3rd circuit. And that should be it. And that even it kind of makes me.
I think you're working with well over a dozen individual connections in your mind.
God, this sucks. I need a longer one. I got it. I have it.
Okay.
Because
Welcome to the channel, Small Water Charters.
Hey, what's up, my man?
Can you time travel with this?
No.
We
What the hell just happened there?
Oh, what do we got?
God damn.
It's rotating on the edge of the toroid. That's an interesting look. Maybe it can time travel this way.
It's not an interesting look, dude. Ugh. It's it's funny though.
Right on. You got this.
And then we're gonna next time I don't got this. Okay?
Well, pulse motor mayhem.
I get it. I don't got it next time.
You got this. Okeechobee in the house.
What up though?
That's right, and we don't take any, we don't do any bets or financial, we don't write down any numbers, nothing like that.
I don't do math really well. I'm an accountant, but I don't do math. Math is not accounting. I'd love for somebody to say, yo, man, if you want this to happen, you need to wrap a 32 turn coil in this gauge and you will get this result.
I like that.
Just tell me. You know? Just tell me.
Hey everybody, welcome to the channel. Thanks for dropping in.
This one might be a little off. Oh, that looks good. So I removed one of the toroids. See if it's what's going to happen here. I might take the other one off. 9 volts. No, it's not. It's not engaging. I don't get it. Maybe they're too far away for this little thing. Worked well on the bigger one.
You did. Hey everybody, welcome to the channel. Thanks for joining us on this Friday afternoon.
Hey everybody.
We are working with our 9-magnet pulse motor rotor here.
Could you move the tinfoil, bro?
Yep, doing some troubleshooting on the
Thank you, sir.
circuit. Well, what I can tell you is to go back in time and not sell all that Bitcoin.
So without this in there, this is what we're looking at. think when I was doing this, I was very distracted.
Ah.
Let's try this again. That's good.
He says, I bet that small water shutter says, I bet that puts out 1.21 gigawatts.
Exactly.
Yes.
Because if it does any more than that, then you don't time travel. You just evaporate into nothing. It's like that, man. I mean, if it's got to be like that, maybe it shouldn't be done at all.
Oh, like the Goldilocks zone.
No, like if you can frickin' do 1 volt over and the capacitor's gonna blow, maybe it shouldn't exist.
Ah.
You know, I just experienced something with safety the other night. Last night. No, it's not a joke, man. Got a building better than that. With a tolerance higher than that. I mean,
You want me to cut the power?
yeah. Holy fuck. Shit. See, I'm too distracted. I can't. I can't engage. I'm not right now anyway. I'm doing zone. I think I'm good though.
Yeah. Hey everybody, welcome to the channel. Thanks for dropping in. Leave us a like, subscribe,
I hope that my frickin' transistors aren't blown. They shouldn't be.
drop us a comment. Let us know if you like watching transistors blow.
Yeah, all you see is a little bit of smoke. For the most part. I've had one catch on fire. Alright, we're gonna start and we're gonna have the trigger coil away.
That's right, we ran out of diesel.
Oh yeah, there we go.
There it goes. Wow. Let me get the... Nice work, bro. There it is.
Now this should continue to excel for a while. Because it is basically a Bendini circuit. Except I took the coil apart. And I separated it 3 times.
Listen to that. That is smooth humming.
Sounds like it's knocking against something to me.
Yeah.
That is smooth. Oh yeah, wow. The magnets aren't gonna fly, dude.
No.
Here, let me get a tack reading on that. Check out the input for this parallel circuit.
$9.98.
I don't think that's right though.
$6.13. $9.96.
It was right.
Yep. 995.
Wow, dude, that is a lot of RPMs for 10 volts.
Hey everybody,
That's
welcome
awesome.
to the channel. Great time to stop in. We got 1,000 RPM with 10 volts.
I thought it wasn't gonna work. Look at it go.
Drop us a like. Let us know in the comments if you love this kind of stuff.
Yeah, please don't compare my motor to a motor that is not 3D printed in any way.
Good point.
It's not fair.
Yeah, we're fabricating all these ourselves.
Yeah, like if I had like all the components fabricated, it'd be like I was saying, fabricated to be perfect. See, that's why that's not good.
Right. Got it.
And I'm gonna have to glue these bearings in there. That's probably what's really happening. It's
Yeah.
coming off the bearing. Yeah, but as you could see earlier on, I was shaking. I'm shaking tremendously. I'm not gluing this bearing in here right now
Okay.
because I will get the glue on the bearing, and then it won't work anymore.
Welcome to the channel, everybody.
And I just don't have a bunch of money to throw around at this right now. But yeah, that happens, and I'm glad we're not going to turn it up right now. Glad that was all it was. Is things getting out of alignment right there. All right, man, maybe I will glue it.
Looks like it's trying to spin. Oh, there it goes. Okay. No, it keeps going.
All right, hold on. Don't.
It's like oscillating back and forth on its own.
That's cool.
Is there any power going through
No.
it? Yeah. That's pretty cool.
But it's nothing. The surface is not even. There's thousands of things that it could be.
I know. I like it looks like a pendulum swinging.
Definitely.
Mhm.
But the way I have the coils is the energy is set up to move in one direction. So
Right.
if it was the coils, it would be moving in one direction.
Right.
But I think that's awesome.
Yeah.
Moving on its own.
Hey everybody, welcome to the channel. Thanks for dropping in. We're gonna do some securing of the bearing. So we're gonna take some time here. Do you want to sit? No, you got it.
I need you to not be engaging with the audience, though, when I'm doing this.
Well, you know what? I'll be right back. Actually, that's perfecto.
Well, you should probably be right back when I'm done with this. I really apologize, everybody. It's just that I need to not mess this bearing up. You know what? Just gonna put it right here. So. Alright. I'm gonna let that dry just for a little bit. Hopefully I haven't got a dab on my finger. Just screwed everything up, but we'll see. Ain't got no gas in it, that's right. it's a shame you couldn't wait. All right, so let's clean it up, turn it on. Heck yeah, man, we got 3 volts in.
Nice.
The bearing is glued in there with some super glue. That was fun though, busting out these old coils.
Yeah.
But this is definitely the strongest build that I've got right now. Well, I don't know that I've been using in the last little while. That's 3 volts in. No went, well, less than 100 milliamps. Got lots of different kinds of coils in here. There we go. Just trying to get that done as fast as possible. Can I give it a little bit more juice? Like 5 total.
All right, it's at 0.1.
Okay, yeah, that's good. It should be at the parallel circuit.
We got amps.
Oh, yeah, we got speed. We got an amp draw. It's working like a charm.
Nice.
Probably set up a generator circuit next. It's kind of what I want to do. Have like a 120-degree drive, and then have like a 6 coil generator circuit. It's all AC. And I'll be using all different kinds of coils for the generator circuit. They're not going to be the same by any means. Oh, come on, kiddo.
We like that.
I'm going to have this coil in there. 22,000 turns of 32 gauge. Along with this coil, 18,000 turns of 32 gauge. We're going to be generating a lot of volts and a lot of amps with this circuit. For what this is, 5 amps is a lot of amps for what this is.
Yeah.
So we can get 5 amps, man. I'll be happy with that. Like, really happy. So, you know what? Why don't I plug in the oscilloscope to one of these circuits.
Welcome to the channel, Inspector Artificial. Appreciate the comment.
Thank you. A little hot. It wasn't necessarily a shock. Really irritating. All these wires getting crossed,
Yeah.
and then double, triple decker crossed, and all this other jazz. All right, wow, look at that sign, square wave with spikes in it.
That is beautiful.
And that's just one of our parallel circuits. So,
Hey everybody, welcome to the channel. Thanks for dropping in. Leave us a like. Subscribe if you like pulse motor material.
thank you, Inspector.
Let us know in the comments where you're from or if you're working on any projects at home. Do it yourself.
That'll work.
$12.50.
Does that seem right?
It kind of does. 8.26. $8.56. Okay, so it's probably,
Probably get up to right around 1,000.
yeah. Inspector asks, is this generating its own amps and volts?
I don't know how to answer that question. I would say yes. If you plug in the oscilloscope, it's generating its own amps and volts, but it won't run on its own. No, you gotta put power into it for it to run. But it definitely will spin for a long time after you turn it off.
Yeah.
I'm gonna yeah, it's starting to shake now. Not shake, but like make a rumble noise. Wow.
1097.
And the first two readings were right around 1200. So I'm going to hook up the other oscilloscope multimeter here.
Inspector said thank you for explaining.
Oh, you're welcome. Did I do a good job? I'm not sure.
I think so.
All right. Good. I'm glad. I'm glad people that you could understand me. All right, I'm gonna turn this on. So it's generating about 3 AC volts. And this is the Oh, it's dying on me. That's what it's doing.
Hey everybody, thanks for dropping in. Welcome to the channel. Leave us a like, subscribe.
2 volts in, ladies and gentlemen. This thing is still moving.
Drop us a comment. Let us know if you love this kind of stuff.
And this is the wave we got for 2 volts. Yeah, it's not going to be ready for a while.
Okay.
It doesn't charge when it's on. And that sucks because that would have been awesome.
Yeah.
But I can plug in this multimeter. See, the oscilloscope is up here. Multimeter's down here. And we'll get some readings on the auto scale real quick.
Did you want to keep going? Just keep going straight through if we're live.
Straight through.
A couple more hours.
Sure, if we are up for it.
All right, I'm up for it. I'm gonna.
But I'm gonna take the next break.
Okay, so then I'll be right back. I'll be right back.
Could you just bring me a water?
Yeah.
Awesome. So we're just testing this one circuit here in front. These two right here are the ones in question. So yeah, we're pulling AC voltage as dominant out of the circuit, 2.5 volts. It's 2.9 DC volts coming out of it though. So it isn't dominant, it just kinda, but it's wow. Alright.
All right, I'll be back in 5. Then I'll plug my phone in.
Alright, so whew. I think it's a nifty little circuit. It's got your pot power, so it goes into the 26 and you get the benefit, or into the 16, you get the benefits of it going into a 16. But then from the 16 it travels into a 24 gauge to a rectifier diode. So it's DC again when it goes into the 24 gauge coil, which is, like I said, a 4-filer coil with 200 turns of 24 gauge. 800 turns altogether. So we got 250 and 800, so 1,050 turns altogether in the circuit. So I'm going to pump it up a little bit, and then I'm going to turn it all the way off. We're going to see how long it rolls for. So 12 volts is 0.5 amps, half a watt or half an amp. Yeah. $12.58. Dude, that is whipping. Alright, 1, 2, 3, let's turn it off. Now we'll see if we have any redeeming style qualities in the rotor after you turn it off. Oh, it's not a free energy device because it'll stop. Free energy is abundant and continuous, and it doesn't stop. That's why, you know, we're not there yet. We would know if we were there. We would know that. There'd be no way anybody could hide that. One, if you invented it, you'd probably be wanting to say something about it right away. Let's get a tach meter reading. It's been off for like a minute now. 572. It's almost going to be like the next time he walks out, we're going to call it. Because this just isn't okay. All right, let's see here. One transistor, two transistors, three transistors. All right. So I think I'm getting near the point where I'm going to need to take like a 15-minute break, maybe longer. But we're going to keep the stream going, and my brother will take care of you while I'm gone. So I'm going to hook these two generator coils up in series to give us a taste of what we're going to accomplish. Alright, so we gotta put some glue on it. I thought we might be able to get away with it without glue. That's our last stick of glue, ladies and gentlemen. That'll be that for changing stuff up. So I just want to get these two generator coils down in here and we'll be good to go. No more glue. Alright. Alright, that's good. Perfect. Yeah, he said he's good to go for another couple hours. He's back. I think he went to go get some food. That might be it. What's up?
What's up?
Shoes. Now this, we'll test both these out. We're gonna try it with a DC connection, and we're gonna try it with a AC connection.
Hey, Bebop, welcome back. Yeah, if we... the free energy stuff makes you wonder. Hey, everybody, welcome to the channel. Thanks for dropping in. Leave us a like. Subscribe if you love pulse motors. Can I take the power from that?
What?
The...
Yeah, if you have to.
yeah.
Nice. Perfect.
Got it.
Alright, so this one is gonna be here. Gosh. Wish those wires were a little longer. Actually. All right, let's give it a little juice. Looks good.
We got ants.
Oh. I wasn't done taking off these. Yeah, please. My bad. Yes, the multimeter is still hooked up to these coils.
Hey everybody, thanks for dropping in. Welcome to the channel. Leave us a comment. Let us know where you're from. If you're working on any projects like this at home.
Well, take care of it real quick. All right. Hey, what's up, son?
I'm looking for things.
Tiggies. I haven't seen them.
You're free to look, Caleb.
Hey everybody, welcome to the channel. Thanks for dropping in. Friday afternoon here in Metro Detroit, and we are working with pulse motors. Hanging with Papa Bale.
What up, though?
And we
Hey.
have a pulse motor wizard in training.
Yeah. Last live I did like a trick.
Hopefully I got all that right. There's only 2 connections, but there's a lot of wires out there, so. Oh, stop it, stop it, stop it, stop it, stop it. Thank you.
Yeah.
I was almost gonna undo that like from
Got it. Need some,
that thing is strong.
need some graphite powder on the shaft, I think.
Yeah.
He's probably James is probably in that window. He isn't on there.
Yeah, don't drink any of that.
The old. Yeah. My favorite thing.
You like old water.
Yeah. I like Sprite, not.
Wow.
Sprite. Yes. Hey everybody, welcome to the channel. Thanks for dropping in.
Old coil. I like the ones that use tape. They look powerful.
Yeah, that's a beast.
Yeah, the more heavier, the more power. Because the wire is heavy, and the more heavier, the more wire.
Yes.
Including the tape. Because the tape is kind of heavy too.
Yeah, the tape.
Yeah. Tape requires strength.
The strength.
Yes, sir. Alright, we're gonna get a reading here.
We got amps. Welcome to the channel, everybody. Drop us a like if you like amps.
Something's definitely not right.
I like amps. .88 volts.
Yep.
No, it's 89.
Oh. No fucking figure. Oh my god.
Every
Wire
time,
snap. Can you cut the power?
every time I look at that through the TV,
Mhm.
it kind of looks like it's 88 and 89.
Yeah.
See an old thing back there.
Need a lighter.
Hey, everybody. Welcome to the channel. Thanks for dropping in. We're working with pulse motors. We're about to clear off some enamel here.
Oh, fire. I'm gonna put this down.
Alright, what kind of readings are we getting now?
So I'm
Wow, heavy DC voltage. Ah, that might be because we got the DC rectifier coming through here.
I don't remember this one being used.
All right. Hey, everybody. Welcome to the channel. Thanks for dropping in. Let's see if we can get some more people in. Drop us a like, subscribe, leave us a comment, let us know where you're from. Let us know if you're working with pulse motors at home.
Perfect.
Alright, I'm back.
777 volts in. 776 now. Like 1776.
Cool.
110 volts of AC electricity in those two coils already.
Fast.
130 volts. .73 volts in with 2.2 amps. Point dos.
So, I'm sorry, I remember when you put like coils and like.
You can hear that humming.
Oh, 158 volts. And 5, I guess.
160 volts.
Yay!
See, that maglev might not be functional really.
All right, tell me when you want to.
No, we're good. We're still climbing here. It's still increasing in speed, ladies and gentlemen. This is still an acceleration phase. 7 is good. We don't need to go any higher than that.
Or maybe below it.
We can turn it down. You want to turn it down to 5?
Sure, I'll do it.
Still got amps.
That's good. I'm not gonna turn it down now.
All right, I think we're
It's
right
at-
Just
around.
leave it. It's fine. It'll
So-
work. It'll work without amps.
It's at 5.
Registering. It's just, I like to have it register amps to make sure that it's working.
No doubt.
Oh no, route 100.
And see how slowly the voltage like decreases. It's like going down like 1 per second, or it was.
Nice.
Yeah, there's something definitely not right with my camera.
Yeah, you like saw that board thing?
Yeah, man, it was despicable. Somebody's been like putting my phone on magnets or something.
I know there's magnets on the bed, but I don't. Well, I picked one up yesterday.
Yeah, I don't know if I'm gonna be able to do this for hours.
Probably gotta get a new phone soon.
Yeah, if you want to take a break and we can go back on later.
Yeah, probably.
I'm in
Give me a
rooms.
chance to get all this sorted out. Excuse me, what?
Almost at 3 hours.
Yeah, that's a nice one.
That's the highest
Yeah.
I've seen it go.
Friday matinee.
Friday night.
Yep, let me know what you're up for, Papa Bale.
Let me check the, see if the oscilloscope is working here.
One time I
Shows
was
about 100 volts.
99 volts.
Nice.
I'm holding this so it doesn't go.
Yeah, I really want to see the oscilloscope on the other one.
Right.
We're
I
going to have to take a break and charge it up.
All right.
Awesome. Thank you very much, ladies and gentlemen. We'll be back later on tonight. Thank you. Please subscribe, hit the like button. Join up. We're going other places, man. We're gonna go back in time.
Back in.
You know what? We're gonna find out that back in time isn't really back in time, it's forward in time.
Wow.
So I was.
I love it.
Yeah, I'm just I'm just throwing it out there. I don't know if I believe in any of it. I believe in it after I build it and it works. Then I believe it.
I love that.
So I was on.
Show me a piece of paper saying it works, I say prove it.
I,
Prove that shit. Alright.
We love you guys. Subscribe. We'll be back on live later. And we're dropping around 2-3 videos a day.
Thank you very much, everybody. Peace out. Have a good day. We'll be back. Bye now.